So in the previous episode, in the previous lesson, we were trying to look at decorators in Python. And what we've discovered, we've realized that whenever you're dealing with decorators in Python, it allows you to modify the behavior of a function or classes without directly changing their source code. Now, in these other remaining examples that we are going to look at, we will look at decorators in more details. This was our first example that we dealt with using decorators. So let's continue with the remaining areas that I feel we could cover it much more better when we look at this in details. All right, so decorators. So in Python, decorators are powerful features that allows you to create the behavior of functions or classes without directly changing their source code. Now, decorators are implemented using this syntax. So when you want to implement decorators, are implemented using this syntax. So let's see how we can implement that. So they are implemented using, you could use single quote, at, then this can be the decorator name. Decorator name. So is the name of the decorator. So this is how you implement decorators in Python. Now, when you use this syntax, it can be applied to functions or classes. So we've learned that this syntax here, like here we have applied my decorator, which is applied to our function. When you hover here, we see it's applied to our function, and we created an inner function within it. So we can also look at one more example that can cover the concepts of decorator, and then we'll be able to look at probably the basic decorators. Now, one thing that I've realized is that you could use basic decorators. Let's look at the syntax. Example 1. Okay, example 2. We already looked at example 1, example 2. Now in this example 2, a decorator is a function that takes another function as input and extends or modify its behavior. It wraps the original function inside another function, allowing you to add functionality before and after or around the original functions. Okay, decorators are commonly used to take a logging, timing, authenticating. Those aspects are the ones which are being used in decorators. So let's see how we can implement this in this syntax. So let's define first a decorator name. So let's define a decorator name. Def my decorator. So this is the decorator name is my decorator in a func. We're passing in an argument function. Now we can define an inner function. This can be an inner function, or we can call it a wrapper. So what this wrapper does, it can take arguments. Let's make it to take arguments for edge, and also quirks. Okay, so this line of code, let's comment it here. This code to be executed before the original function. Before the original function. So now we can also have this code here, which we can call a variable result that takes in the function for arguments. Now another line of code can now be executed after the original function. So this code to execute after the original function and returns results and return wrapper. So the first one will return result and the second one return wrapper. So let's see how, if you run this, what would be the output. Definitely we're not printing anything, so we don't expect any output. This display here is coming from this other text here, this first line of code that we have written. We can comment that one out and we remain with our last example. So that is how you implement Decorator. But let's now look at it in a more how to apply Decorator. So we had created a function. We can now improve this and then we apply it in a more elaborate example that we can look at Decorator in a more simple way. So how can we do that? We can now allow it to print function just to display some text. Okay, immediately after the first argument we can just say let it print this is my decorator, close the quote, before function execution. Then we can also have it to print after my function execution, which it can be after the results. So let's do it after the result. To print after function result execution. So now it will return our result, return our wrapper. Now let's apply our decorator. So it's going to be my decorator, which has to be to the function name that we declared first. Now we can define my function, not my decorator. Can define my function, we're not passing in okay, let's pass in the argument func, and then for it to print inside the function. This will print what is inside the function. So inside the function. Okay, so let's call my function. Alright, now in this process here, we can see we already have one problem here. Line 14, 553. We didn't close, so we can close that. That problem is solved. So now let's go ahead and run. Wow, we still have some errors here. The function argument doesn't take the function, so let's just remove this. And this is another way of dealing with debugging. We could clear it one more time. Okay, so you can see now it works because we do not have to pass in that argument, and that's how you can go ahead be debugging some of these codes. Okay, so this is how you apply decorators. And when you apply decorators to a function, you use the decorator name syntax directly above the function or class. So you can use it above, the way we have implemented it here, above the function or the class. So now let's look at decorating class. Let's look at decorating class. Let's have one more example. We can comment this out. If you have any question, please you would leave it in the comment, then you will be able to respond to it. Okay, so let's see how we can look at example, I think 3. I'm not so sure about it, but should be our second example. So applying decorators in a function, this can also be useful. In this case, we can decorate function wrap that wraps our class definition, allowing us to modify the behavior of the method and add the attribute to the class. Let's see if we can implement this. So my decorator function is applied to my class, and the decorator will replace my class method with the modified version of the prints method instead. So let's see how we can do this in real life example. Just a second. Okay, so we can now proceed here and look at this other example. Now let's define. We're now looking at let's define my decorator function. My decorator, we will use a CLS for class, Now we can have our class modified class. Modified class. Now from the modified class we can initialize our construct method self. So we pass in age for the arguments. Then we can create an instance for self instance, which will be the variable. Then we have our function that we pass into the argument age, and now what we can do, we can define a method, my method, and my method with self check, and then print modified method. Modified method, and then we can return modified class. Okay, now let's create the decorator, my decorator. So it's going to be class my class, then define, instead of calling it my function, we can have my method. Okay, this time round we can do the self, and then we having some, because we called it my class, we should have actually used here class, and it's complaining, so we need to fix that a bit. Okay, I think everything is just going to make sense if we do a class, my class. I think that helps to solve that, because I didn't type that. Okay, so I think those errors are now moving. Then we can now print my original method. Okay, so let's check it out in the instance here. So my instance, which we created here, my instance variable, which to check my class, and my instance method check the method. So we have two problems here. We could fix this by okay. So instead of having this, my class should have been defined as a function, so that it passes to call the modified the original class. So let's save that and run. So it now outputs modified method. So that is how you can see clearly in this example that the function is applied to my class, and then the decorator replaces the original my method with the version of modified method instead. So the modified method instead. Okay, so that's how you implement decorators. So let's look at one more other concept. This time round, let's look at context managers, then multi-threading and multiprocessing. So let's look at that context faster, and we should be able to move on.